So the last thing in skill 14 is we're going to look at the inverse trig functions. So this is essentially sort of these trig functions running in reverse. So normally what you're doing is you're sort of doing it from the perspective of an angle, right? And you're sort of setting up what you're doing is sort of setting up the ratio between the side lengths and getting a number out of it. And so what you can do with the inverse version, so inverse again kind of means the reverse. So rather than kind of having an angle and then sort of getting a ratio of the side lengths, what you can do is sort of starting with the side lengths, you can actually use this to reverse engineer what a different angle value is in a triangle. So the way we notate it, sine inverse, cosine inverse, tangent inverse, is with this little sort of -1. This is a fairly typical sort of math way to sort of notate an inverse function, which is sort of, again, an operation or some sort of formula that we're sort of running backwards. And so the same kind of setups apply, right? Sine sort of still has to do with the opposite over the hypotenuse. Cosine is the adjacent in the hypotenuse. Tangent is the opposite in the adjacent. All those relationships hold. And so what's happening here now is instead of the sine of the angle is this ratio, you do the sine inverse of the ratio, and it spits back the angle value. The operations here, the sort of the way we're going to sort of do this practically is going to be with a calculator. Let me see if I can get this to sort of show up okay. So this is my sort of classic Casio calculator. A couple things to watch for. You're going to want to, do you see the little, if I zoom way in, you see how this has a little D on it for degrees? That's going to be something you want. We're sort of doing all of our angles in degrees. There are other ways to measure angles, sometimes in radians. So you're just going to want to watch out that you're not in radians mode. Any sort of R or RAD is something to watch for. You can see in this calculator, right, the trig functions are here, sine, cosine, and tangent. And then you can sort of see in, right, gold or orange, the inverse versions, sine inverse, cosine inverse, tangent inverse. And the way this is notated, right, is it's color-coded with my shift key. So what this means is if I'm trying to find and use an inverse trig function, I'm going to use this shift key. So let me just sort of show you what that would look like. So shift, and then if I do sine, right, it brings up sine inverse. And then what I'm going to do is I'm going to put in a ratio, right? So one of our sort of sine ratios, and I'm going to put in the last video, at one point we used 0.79. And if I have it calculate that, what it spits out is sort of 52.1855, right? So this is about 52. And if we think back to that video, or if we look back over here, right, there is my 0.79, and it went with 52 degrees. So the idea is if I put the 0.79 into this, I'm getting the 52 back out using the inverse function, right? So there it is. You can kind of see it in this layout. The sine inverse of 0.79 brings me back to the 52 degrees. That's the just sort of basics of the mechanics of how we're going to use our calculators to sort of do these problems. What are these problems going to look like? So then our example here is something like example number 3, skill 14. So given a triangle, what we're going to do is find one of the unknown angles here. Now, always, these are going to be right triangles. So we know one of the angles here is 90 degrees, right? The one up here in the corner is 90. So we're going to find the theta value here, sort of in this bottom left. Our perspective, of course, right? The opposite and the adjacent and the hypotenuse. We have them marked here. I'll sort of also just sort of mark them, right? My hypotenuse is the 15 across from theta is my opposite, right, is my 9, and then the adjacent is 12. And so what I can do, I really only need to do this once. In the example here in the book, they actually do it multiple times. And so the idea is you say the angle should be the sine inverse of the opposite over the hypotenuse, right? So that would be 9 over 15. So if you do that and you divide it, and then you take the inverse, it's going to get you a 36.9 degrees. Again, this is a calculator problem, so there's not really a lot of actual sort of math to write out in some of these. We're kind of just subbing them in. There's not really a great way to do this by hand. That's enough. That gets us the value. You can sort of do a double check and confirm this with the cosine. If you do cosine inverse and you use the adjacent and the hypotenuse, so the 12 and the 15, it should give you the same angle, 36.9. It might be, rounded just a little bit one way or the other. So you might get values here that are just a little apart from each other, but they should be very, very, very close. Similarly with tangent, if I did an opposite over an adjacent and I used the 9 over 12 instead, it's really just a matter of sort of picking whichever sort of ratio you like the best and whichever function you like the best. All of them should get us back to the same angle, in this case, the 36.9. If we do another one, just sort of pulled from the homework. So again, you guys are doing the odds for homework in this section, so I'm doing some evens as an example. So if we take number 14, 25.8, 23.1, and this 11.4, I'll shift over to where I've got it written out. Extremely scientific and mechanically sound, hold the paper kind of method. Very high tech over here, extremely high tech. I'm practically Batman with all the technology I'm working with. So this is the triangle rewritten. I've identified, right, as always, so from the perspective angle, right, my theta up here, up top. The opposite is down here in the bottom. The adjacent is next door, and the hypotenuse, of course, is the long side. And I'm just going to do it from two perspectives here. So if I do the sine perspective, sine inverse, so sine is going to be the opposite over the hypotenuse. So that's 11.4 over 25.8. So that's my fraction. You can sort of actually divide it. That would be a 0.44, right? And so if I do sine inverse of 0.44, it's going to get me this 26.2 as an angle, 26.2 degrees. If I want to double check it, which is never a bad idea, I also did a cosine version. And you can kind of see I get a slightly different angle, but that's okay. They're very, very close together, so it's very reasonable to sort of assume that we're on the right track with both of these. So my cosine values are the adjacent over the hypotenuse, so 23.1 over 25.8, adjacent and hypotenuse. That fraction would be 0.895, right, as sort of a decimal. I got to sort of do that to get it into the calculator. Cosine inverse of that decimal value should get me to 26.4. So maybe these two, in theory, kind of meet in the middle. Maybe if we did a tangent version, we'd get a 26.3, and that would be kind of a compromise value. What's happening here, of course, is, we're not really taking these answers out to 3, 4, 5 kind of decimal places long, and so you get some slight disagreements here on some of the values. But if we're calling this in the end 26 degrees or something, then we're obviously fine. So that's the basics. That's the basics of using the sine inverse. You can sort of imagine using this kind of thing to sort of find different angle measurements when you sort of know different length measurements. That's the idea.